In this video, we're going to do a few more practice problems. The first problem I want to look at is similar to problems 2A and 2B on the worksheet. Here we have a point on the unit circle, but this point, the coordinates here, -4/5, 3/5, are not do not correspond to any of the 16 angles. Nevertheless, this point is on the unit circle, and we can demonstrate that. The unit circle is this. It's defined by x squared plus y squared is equal to 1. And if we put in our values here, -4/5 squared plus 3/5 squared, well, that's going to be equal to, we want to know, is that equal to 1? Well, -4/5 squared is positive 16 over 25. And 3/5 squared is 9 over 25. So when we add those, we have a common denominator, so we have 25 over 25, which is equal to 1. So yes, when you square the coordinates and add them together, you do get 1. It's just a right, it's just a right triangle, but where x squared plus y squared is equal to 1. Now, having said that, that's not necessary for solving the equation or solving the question. The question for these problems in 2 are just find the 6 trig functions that correspond to this angle, whatever it is, whatever this angle t is. Finding out what that value is another topic later in this unit. Anyhow, to find the values is pretty straightforward. I know that the sine of my angle t is just my y value. It's 3/5. The cosine of t is equal to -4/5. And the tangent of this real number t, real number again, it's just how far I am. It's something like, just to give you an idea, there's 1 radian, 2 radians. It's something between 2 and here's 3 radians. This is, of course, pi radians. It's something between 2 and 3. Nevertheless, tangent is just sine over cosine, and that would be 3/5 over 4/5 negative, which would be -3/4. These 5s cancel out. So that's -3/4. And that should, I want you to see that terminal side does have a slope that's negative, slope of -3/4. And that's something visual to think about when you're thinking about a tangent. I'm here in the second quadrant. I have a negative slope, negative tangent. Now, the cosecant. Now let's do the reciprocals. Well, a reciprocal of 3/5 is just 5/3. The secant is just the reciprocal of negative 4/5, which would be negative 5/4. And the cotangent is the reciprocal of the tangent, which would be negative 4/3. Let's erase this stuff right here. And that's the answer. So when you know coordinates for any point on the unit circle, it's going to correspond to those coordinates correspond to some real number t as the argument to these trig functions. And evaluating the trig functions is a simple matter of applying our definitions for sine, cosine, tangent, and their reciprocals, cosecant, secant, and cotangent. Okay, fair enough. Now we want to be able to use period as an aid. So this is, let's look at a problem like this. Suppose you want to know what's the sine of, and I'm just going to come up with a number like negative 3 pi. Okay, well, negative 3 pi is not on the unit circle. But remember what in the first set of problems, if we can come up with a coterminal angle for negative 3 pi that is between 0 and 2 pi on the unit circle, then we can evaluate that. If we come up with the coordinates, then we can evaluate quite easily. Now, negative 3 pi, to come up with a coterminal for that, I'm going to add 2 pi. Remember, add a full rotation. Negative 3 pi, by the way, is this. There's negative pi, negative 2 pi, negative 3 pi. And it should be, maybe you can see right off, we're ending right here. Without drawing the picture, negative 3 pi plus 2 pi is equal to negative pi. Well, it's still not between 0 and 2 pi. So if I do this, negative pi plus 2 pi is equal to 1 pi. And that I do know. The coordinates are 1, negative 1, 0. So the sine of negative 3 pi is equal to the sine of pi, which is 0. That's using period as an aid. So suppose we want to do, let's just do a little bit different one using period as an aid. Suppose I say, what's the tangent of, I'm thinking here, 6, 12, 19 pi over 6. Again, you can see it's over 6, but this is not in our range between 0 and 2 pi. If I subtract 2 pi, maybe I'll be in range. Well, 19 pi over 6 minus, and this is over 1. So I want to get a common denominator of 6. I multiply 1 times 6 to get 6. I multiply 2 times 6, that's 12. So the tangent of 19 pi over 6 is going to be the same as the tangent of 7 pi over 6. 7 pi over 6 is a point I know, it's right here. And really the angle that I'm 19 pi over 6 is coming around, it's going all the way around like this to there. This is 7 pi over 6. Our coordinates are negative root 3 over 2, 1/2. And so the tangent is going to be y over x, or negative 1/2, there's a negative there, negative 1/2 divided by negative root 3 over 2. Now, like up above here somewhere, or in the last video, these denominators are both 2's, they can be canceled out. So this is negative over negative is positive. And you notice that tangent, that slope of that terminal side is positive slope. And we want to rationalize that denominator. So what we get is root 3 over 3. That's the tangent for 19 pi over 6. Now, a little bit of how to use a calculator. So let's move down here a little bit, bring up our calculator. Suppose you want to find just an arbitrary number, real number, cosine, say of, let's just say 3, the cosine of 3. Now, that 3 we know is a little less than pi, so it's a pretty shallow angle. This angle is about like that. I mean, that's the arc length 3. Here's about 1, here's about 2, and there's about 3. Now, I don't know what these coordinates are. And so it's not a unit circle common angle, but it is on the unit circle. We're still calling this 1. So what I'm going to do is, when I do this, I want to be sure my mode, press your mode key and make sure you're in radians. And then you can quit out of that and just say, well, what's cosine of 3? It should be negative. Negative 0.9899, or negative point, if I'm rounding to 4 places, it's really negative 0.9900. Take a look at that. I'm rounding to 4 places, and this 9 rounds that to 10, which rounds this to 10, which rounds that to 9. Okay, let's try another one. Sine, let's do the sine of 3. Now the sine of 3 is going to be a small number. This x, this y value is pretty small. The sine of 3. It's positive 0.14. Let's take a look at it again. 1. All right. Now, suppose I want the secant of 3. The secant is not showing up on it. That key does not exist on this calculator. It doesn't exist on many calculators. You have to get a pretty expensive calculator to find a secant. Well, it doesn't have to be expensive, but generally you don't see secant, cosecant, or cotangent on a calculator. You just see sine, cosine, tangent. The secant, though, we know is 1. The secant is the reciprocal of the sine. So this is the same as 1 over, it's the reciprocal of the cosine. I misspoke. So we can do this. To find the secant, we say, well, 1 divided by the cosine of 3. And that's the cosecant. I have to look at it again. Negative 1.0101. Now, just to show a couple other keys that do this, this button right here is the reciprocal key. And if you press it after getting an answer, I mean, just press it after you have an answer, it'll give you the reciprocal. And there you go. The reciprocal is, this is our value up here. If I say, you know, what's the cosine of 3? I get this value. If I want the secant, its reciprocal, I can just press, give me the reciprocal of that number, and I get this. That is the secant. Let's do the tangent on this. The tangent of 3. That's negative 0.14. So the tangent of 3 is equal to 1425. 0, negative. Notice it's got a negative slope, negative 0.1425. If I want the cotangent, I can do that in a couple of ways, but if I already have the tangent, I'll just press this key. It's negative 7.0153. Negative 0. Negative 7. Let me look at that value again. Negative 7.0153. These two things, I guess, they're both negative. If I were to actually try these approximations, negative 0.1425 times negative 7.0153 gives me something really close to 1. I've rounded, so I'm not getting exactly 1. But to the nearest, you know, I'm getting 0.9999 when multiplying. So that's how you do all your trig functions on your calculator on arbitrary numbers. We'll end there.